Hi friends, welcome to our channel. Let's look at problem 3805, Count Caesar Cipher Pairs. So in this video, we are going to first get a presentation of each word. And then, according to the presentation, we are going to group the words. And then we do the final computation. So here, the problem statement is very easy. So given an array of words, containing n strings, and the strings have equal lengths. So two strings s and t are similar if we can apply the following operation any number of times. So here possibly 0 times, so that s and t becomes equal. So basically we shift one string to get another string. So in this way specified by the second bullet point. So here, the problem is a counting problem. So we want to count the number of pairs, indices ij, such that the two words are similar, right? So in the first example, so these two words actually are similar. So here you can see after shifting 6 times, we get the same thing. So in this case, so because the group consists of a single group, there are two. So we can only choose the two. So we don't need to worry about the indices, because as long as we choose two out of C, if you have K, then naturally they have different indices. One is small, one is large, right? So this is the first example. In the second example, so here word 0 and word 2 are similar, and word 1 and word 3 are similar. So actually this consists two groups. So this two forms one group, and this two forms one group. And then from each group you need to choose two, and each has only one option respectively. So 1 plus 1 is 2. So here, if you look at the problem size, so m times n is bounded above by 10 to the power 5. So I would say this is a decent size problem. So actually you can solve this problem using the hint. It's rather straightforward. First, you need to fix for example, you can assume what's the result if I want to shift the first word, first character in the word to be A, and then the others should be fixed accordingly. Then you can get a representation. Then you can group the whole list according to that representation, right? Then you have if you have a group contains keywords, then it contributes to the final return by choose 2 out of k. That is k times k minus 1 enter the division by 2, right? Now let's carry out this program, right? So first I'm going to write a function, hyperfunction called normalize, right? So I want to, given the words, I want to get a tuple representation, right? So let's see. Get a representation. So for this, let's get the length of this word, right? So you can use m in because in this problem the length has m. Each length has length m. So here let's use m, and then we can initialize our result to be 0 times m. The first one I want to choose it to be a. So I use the index in the alphabet as the representation in that position. So this way we will need to compute. So what's the distance we shifted? So we can do this as a reference distance. That is the ordinary number of word 0. So minus the ordinary number of this character A, right? So then we are going to set the remaining positions. So basically for I in range, so 1 to m, so ending before m, right? So the representation for I would be this. So ordinal, the word I, so minus this reference distance. But this ordinal number may be less or maybe greater than the ref distance, because it's cyclically. So we are going to add 36. And then if this one is greater than 0, so we just use this one. So in other words, we are actually doing operations like this, right? So then you can return this. I'm going to use the representation as a dictionary keys. Therefore, here I'm going to make it a tuple. So here you can use this tool as a test, right? For example, normalize Fury, and let's print them, right? Print. So normalize layout. So this way, they should have the same representation, right? So this is their representation. They're in the same group. Therefore, you choose 2, you get 1, right? So now let me comment out this line, and then let's do the grouping. So do grouping. So here I'm going to use a dictionary, right? Collections default dict. So because I'm going to count, I'm going to use an integer. So basically for word in words. Then what we want to do is D. So the representation of this word is normalize this word. So then we're going to count increment by 1, right? So this way, actually, we are going to group all these things. So you can look at this example. This has 1 group. This has 2 group. Let's print out. So for the first one, you get 1 group. The group name or the group key is this, and then the number of words is 2. So 2 choose 2 is 1, right? This is the first example. In the second example, so you have 2 groups. One is named like this, the other named like this. So each group has 2 words. So 2 choose 2 is 1. So we have 1 plus 1, that is 2. So now let's return. So here just the sum. So count times count minus 1, enter division by 2 for count in the D values, right? If count is greater than 1. Actually, we don't need this filtering, because if your count is 1 or 0, so this mathematical expression gives you 0, right? Also, you can set a default, some count is 0, right? But let's just run using this format. It passes the 2 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So here, I guess the coding is rather straightforward, and the idea is important. The main idea is to represent each word by eliminating the cyclically invariant nature, right? So with that said, I guess that's it for the current video. Thank you for watching.